Dr. Romano. It looks like you're up to physics again.
Hi, I'd like to go over a problem with you today to illustrate the law of Newton. This is going to be known as the frictionless pulley or the Atwood machine. Let's have a look. We have two masses attached to a pulley. We have a 5 kilogram and a 10 kilogram mass. What we want to do is we want to find the rope tensions, we want to find the acceleration of the system, and the distance moved by the 10 kilogram mass in 2.31 seconds if we started from rest. The first thing that we're going to do in these problems is I'm going to make two assumptions. First assumption I'm going to make is that rope tensions are always equal. So before we start, T1 is T2 is equal to T2. I'm going to call this rope T1 and this rope is T2. So this would be mass 1 and this is mass number 2. The second assumption that we're going to make here is that the 10 kilogram mass is heavier, is going to move down. And this is going to be the key to the problem because if it moves down, the acceleration will be negative. So I'm just going to put that to remind you that this is going to have a negative acceleration and this guy is going to go up. This would have a positive acceleration. All right. What I'm going to do is to draw a free body diagram to isolate the mass. Never forget what my professor once told me. Ropes always pull and never push. So therefore, if it pulls, that means that the tension must be going up. That's T1, and the mass times gravity, which is the weight, is going down. So we have M1G going down. So these are the two forces that are operating on the 5 kilogram mass. T1 up, and the weight M1G down. So I'm going to first write the law of Newton, as you remembered, is F equals ma. But I'm going to modify it a little bit. Since we're in the y direction, the sum of all the forces in the y direction is equal to may. What do you see with your eyes? Going upward is T1, going downward, so it's minus. So we have T1 minus M1G equals M1A, and I bring the M1G to the other side, and there's my first expression. T1 is M1A plus M1G. Now let's go to the second mass. We have the 10 kilogram object. You have T2 going up, ropes only pull, never push. You have M2G going down. The sum of the forces in the y direction is may. There's nothing going on in the x. You have T2 minus M2G is M2, there's the trick, minus A, because it's going downward. Bringing M2G to the other side, we now get T2 is M2G minus the M2A. Notice I just brought the minus through here. Okay, the physics is over. There's your two key expressions. For a pulley, T1 equals T2. So I'm going to set M1A plus M1G equal to M2G minus M2A. And I simply plug in my numbers. There's the mass, there's the G, there's the mass of 2, and I solve, and I get 3.3 meters per second squared for the acceleration. Actually, I did B first. So let me just change this. I did B first. Now let's go to A, find the rope tensions. In order to get the rope tensions, I can use either one of these equations. Let's use the first one. T1 is M1A plus M1G. There's M1, there's the A that we just got, there's M1 again, there's the G, and I solve, and since T1 is T2, either one would have gave me 65.5 newtons. To find the distance moved, I'm going to use the distance formula. S is 1/2 AT squared plus VIT. Well, the VIT is 0, it started from rest, so that goes out. So it's 1/2 the acceleration, which we found was 3.3. The time was 2.31 seconds in the question. We square it, and we get 8.8 meters. And there you have it. That takes away the mystique of how to do the frictionless pulley. I've seen teachers make a mess of this. Do it the way I showed you, but the key thing is to draw that free body diagram first. And secondly, isolate all the forces. And remember, one of the masses you got to assume goes down. The heavier one obviously would be down, so the acceleration is negative.
Thank you, Dr. Romano. You made it so easy. I like that t-shirt.
All right, good luck to you. I'm glad you do. Bye-bye.
Goodbye, Dr. Romano. Good luck to you, too. Good day to you, sir.